In this video, we're going to discuss CRA models for quotative or measurement whole number division. So we previously talked about the fair sharing division, so now we're looking at quotative or measurement division. So you'll notice that this is just for our divisor and the quotient for measurement division. It's just switched from that fair sharing. So our dividend, or that first number, is still our total amount. And then our divisor is telling us the size of each group, and we want to find out how many groups with that size can be made from that total amount. Okay, so we'll go through the same model types, showing this for the measurement division. So we're going to start with the set model. We're going to use the same problems all throughout, just so we can kind of see the difference too. So for the set model, again, we're just counting the number of objects in each group. We're not doing any measuring any dimensions. So 12 divided by 3 says that we have 12 counters in this case, and we want to create groups that have a size of 3. So we're not creating 3 groups, it's groups that have a size of 3. Okay, and we want to figure out how many groups of that size can we make. So rather than putting this one at a time into different groups, I know that each group has to have a size of 3. So I'll make one group right there that has a size of 3. Okay, so that's one group right there. I'll take a second set of 3 and make another group there. That's 2 groups. 3 groups that have a size of 3. And then finally 4 groups that have a size of 3. Okay, so then we're not going one at a time, putting them into equal groups. That's that fair sharing, right, where we're sharing fairly as we go along. Here we're taking a measured amount or a certain quota, right? That's a quotative or measurement division. Taking a certain measure and placing that into each of the groups, and then we'll find that we have 4 groups that have that size of 3. So that's a concrete model. And then representational. It's kind of similar. I know that I'm going to make groups that have a size of 3. If I wanted, I could move these and kind of cross these off. I could also, I'll say this is going to be one group that has a size of 3. It's a second group, a third group, and then a fourth group. Okay, so we can just draw some kind of grouping, drawing either circles or squares or something around those, just to show that these 3 are grouped together. That's one group that has a size of 3, so you can see that we made 4 groups with that size. Okay, so that'd be example of the representational model, and then again the abstract model is just going to be that 12 divided by 3 equals 4. Again, noting that that 3 for measurement division, that divisor is telling us the size of each group, not the number of groups, and then our quotient is the number of groups. Okay. All right, so that's the set model. Now we'll look at next type, which is going to be that length model, where we have an actual length that we're measuring. So here again we have a length of 12, and we want to divide this by 3. So divide this into lengths of 3, or groups that have a length of 3. Okay, so here's one length of 3, the second length of 3. So again, I'm not putting lengths into one group at a time, taking those kind of chunks, those measured amounts of 3. So a third group with a length of 3, and then a fourth group with length of 3. So you can see if we have that starting amount of 12, some length of 12 units, divide those into groups that have a size or a length of 3 units, we can create 4 groups from that original amount. Okay. Right, so that's a concrete model, that measurement division. And then we'll look at number line here for our representational. I'm going to do the small ones again. There's one at a time. Okay, so we have a total length of 12, and we want to divide this length into groups that have a length of 3 units, or a size of 3. Okay, so in this example, we don't need to break this into separate number lines necessarily. Right? We can say that here's one length of 3 right here, right? And then a second length of 3, third length of 3, and then there's our fourth, right? So this is our first group, second group, third group, and then fourth group. So those are 4 groups that have a length of 3 there. Okay, so here we're just breaking those into those measured amounts. Okay. So that's representational model, and then again, abstract model is going to be that 12 divided by 3, kind of make, emphasizing that here that divisor is the size of each group. Okay, we'll look at an area model. One thing we'll notice with the area models and the array models is that the type of division, again, we can kind of, it's not as crucial for these model types since we're just looking at rows and columns, and there's not like a obvious, there's not an obvious category that has to be the group. But we'll just kind of go through these examples. So again, 12, we have 12 square units. We want to divide this into groups that have a size of 3. So again, the group can be whatever we want. So just to kind of show how this type of division could basically align with the previous model that we looked at for the fair sharing, I'm going to say that the groups are columns. Okay, so each column here will have a size of 3. Okay. Let's move these over. So again, the columns. So you'll notice this is pretty much the exact same process that I went through in the fair sharing. So that's just kind of a characteristics of the area and array models. Okay. So there's one column that has a size of 3. There's a second column that has a size of 3 square units. Third, and then fourth. Okay. If we wanted to say, rather than columns having a size of 3, if we said rows that would have a size of 3, our model would just end up looking like this. Right? So it'd have the look the exact same, just rotated. Right, that'd be my first row of 3, second row, third, and fourth. Okay. So that's a concrete example for the area model, and then we'll do the representational one. It's going to be pretty much the same. Okay, so again, if we want columns with a size of 3, right, this one I will redraw these and cross them out as I go since I want them to be arranged as an area model. Right? But there I'm just crossing all 3 off at once. The second, right, a second column that has a size of 3. Third, and then fourth. Okay. And then again, abstract model, 12 divided by 3 equals 4, where that 3 is saying the size of each column in this case. If we were to rotate it this way, we could say 3 is the size of each row, and that's what that model would look like. Okay. That's area model. And our last type is going to be the array model. Okay. So I have 12 counters. It's just a set model that's arranged in that row and column structure. So 12 counters. The size of each group is going to be 3. Here I'll just do the rows. So I'll say each row has a size of 3. Okay. So there's one group or one row with a size of 3. Second group or row, third with a size of 3, and finally the fourth. Okay. So again, here it's saying that 3 is saying the size of each row. Okay, so there's 3 counters in each row, and maybe we can make 4 rows with that size. Okay. So that's the concrete. Our representation is going to be pretty similar to what we looked at with the area model and similar to the counters. Okay, so I'll say if it's rows with a size of 3, there's one group or one row, a second group or second row, a third, and then a fourth. So if I start with 12 counters and divide these into rows that have a size of 3, I have made or organized this into 4 different rows. Okay. And again, abstract model is going to be that 12 divided by 3, where 3 is the size of each group, and then 4 is the number of groups I've made.